Alright, here in 4.5 we have some work that you've done previously in an intermediate algebra class, and it's solving polynomial and rational inequalities. And it's pretty nice. You just want to find out where the graph is above the axis and below the axis. And so one of the things that we could do is utilize the graphing techniques that we are learning right now to reinforce that. And another way is to do it the traditional way that you learned in an intermediate algebra class. And you might have forgotten, so we'll talk about it here. Let's look at the first equation that we need to see. It's a polynomial inequality, and they want to know where this thing is less than 0. No problem. What you could do is you could graph it. And what are you going to graph? You're going to graph f of x is equal to x minus 4 squared times x plus 6. That would be the easiest way to see what's going on, and then I can put it back in what we did in intermediate algebra. So we would take note of the zeros, and one of them is down here at negative 6 and the other is at 4. And we know about this thing. It's gonna touch right here, bounce off, and it's gonna pass through. We just need to know where we're at. So let's just pick a number. Let's pick negative 100. If we pick negative 100, I'm picking something weird like that because we really don't care what the number is. We only care about where we are. So if I pick negative 100, notice that negative 100 minus 4 is going to be negative, but squared will be positive. And negative 100 plus 6 would be negative. And a positive times a negative is negative. So we are below the x-axis here, coming up to this 0. We know we're somehow coming back down to this other 0, touching and going right on up. So where is this thing less than 0? Only from negative infinity all the way up to negative 6. Now we're not going to include the negative 6 because it is it's flat out 0, and we need to be less than 0. Remember, the traditional way to do this would be to plot all the zeros on a number line. Right? So if you go back to your intermediate algebra book or notes, you'd see yourself do this. Test a point like negative 100. Realize that it's negative. Because negative 6 is odd multiplicity, we're going to pass through. And after the 4, we're going to stay the same sign because it touches. And so then we would have only one region in which we are negative, and it would be the negative infinity to negative 6 region. So I don't know if you feel like it's a waste of time to graph because you're getting pretty much the same information with our traditional is the word I should have used, approach. So we could have something where you have to factor, right? No problem. X cubed minus x squared minus 72x is greater than or equal to 0. So this time we're looking for it's either positive or 0. So what do? Well, you need to make sure that there's 0 on one side. Check. You need a factor. Because what we need are those zeros. And then you can factor this in a heartbeat. You know the factors of 72 that are 1 apart. And just like that, you get some zeros. So this time I won't graph it. We have a 0 of negative 6, we have a 0 of 0, and we have a 0 of 7. If I pick my same negative 100 and look at x times x minus 7 times x plus 6, negative 100 would be negative. Negative 100 minus 7 would be negative, and negative 100 plus 6 would be negative. So what do I get? 3 negatives make a negative. Jump to the other side of negative 6, well, I just have to look at its multiplicity. It's going to pass through. At 0, it's going to pass through. And at 7, it's going to pass through. And so, you can double check that by picking something in here. Like if that, apologize. I didn't really pass through at that 0. I'm glad I took a second look at that. At 0, it's going to pass through. And at 7, it's going to pass through. Sorry, it should have changed signs at the 0. But let's double check. Let's pick something like 5. If I plugged 5 in, I get 5 times 5 minus 7 times 5 plus 6. That's a positive times a negative times a positive, which is negative. So it will agree with all of that. So you don't have to choose points in each one of the regions. That's how they had us do it in intermediate algebra, because we didn't talk about multiplicity back then. Now that you know about multiplicity, you can get it really quickly. So where are we positive or 0? From, let me get the pen back, from -6 to 0, including those endpoints, and then also from 7 to infinity. And we would just type that in. That's the work that we're doing. You will have rational functions. X plus 9 over x minus 7 is less than 0. Equally as easy. You know from the graphing that we just did that you can switch signs around a vertical asymptote, and you always will if that vertical asymptote has odd multiplicity, which ours does. So we have to respect the 0 of -9 as well as the vertical asymptote of 7. This number line is just for reference, so you don't have to space things out at all. Let's pick our -100 again. I'd have a negative divided by negative, which is positive. Jumping on the other side of -9, it's going to pass through, so it'll be negative. And then this is a vertical asymptote at 7, but it's odd multiplicity, so if it's going to negative infinity on one side of 7, it's going to positive infinity on the other. So where are we less than 0? Between -9 and 7, not including those endpoints because we don't want to be 0. Last example. X squared times x plus 5 times x plus 6 all over x plus 7 times x minus 1. And we want to know where that's greater than or equal to 0. So what do? You get all of these zeros or undefined points on a number line. So the lowest one I see is -7. There's a -6. There's a -5. There's a 0. And there's a 1. It's going to have different signs in each one of those, but it doesn't always alternate. Let's watch this happen. Let's pick our -100 again. If I pick -100, anything squared, right, I'm coming right back up into this, anything squared is positive, -100 plus 5 is negative, and -100 plus 6 is negative. On the bottom, -100 plus 7 is negative, -100 minus 1 is negative, and 4 negatives make a positive. So I'm positive for every number below -7. Now -7 is a vertical asymptote, so I'm going to jump to the other side. I'm going to jump to the other side, and I'm going to be positive. And then at -6, I'm going to pass through, and I'm going to be negative. So if you're thinking, well, how do I really know that's the case? I suppose you could do the old intermediate algebra concept of plugging in a number represented from each region. Again, you don't care about signs. So -5.5 squared, anything squared is positive. -5.5 plus 5, negative. -5.5 plus 6, positive. -5.5 plus 7, positive. -5.5 minus 1, negative. And 2 negatives make a positive. And so of course we're so did I do that right? I was just thinking about this. So oh no, I didn't do it right. Sorry, that's where I went wrong. So checking would be well versed, right? I said I passed through the -7, but I didn't switch its sign to be negative. This guy here becomes positive, so maybe that would be good. So you saw what I did there. I talked about passing through, but then I didn't put the other sign. I kept it both positive. If it's positive infinity on one side, it's going to be negative on the other. And so I caught that only because I checked a region, so might be beneficial. But this is going to be, as we go through here, this is going to switch signs and be negative. At 0, though, what happens? 0 has positive multiplicity, even multiplicity, so it's going to touch, and therefore it's going to stay negative. We can try that again. We can try something like 1/2. 1/2 squared is positive. 1/2 plus 5, positive. 1/2 plus 6, positive. 1/2 plus 7, positive. 1/2 minus 1, negative, so it will be negative. And then on the other side of 1, it's going to jump to the other side, right? It's going to go from negative infinity to positive infinity because that's a vertical asymptote. So look at what the question's asking. The question's asking where we're greater than or equal to 0. Well, we see from negative infinity, whoops, not negative 8, from negative infinity all the way up to negative 7, we are positive. Now, here's the key. I have, and it will totally be marked wrong if you use a squared bracket. That should not be used because negative 7 doesn't make us 0. Negative 7 is not even part of the domain. You can't even include it. So don't get in your mind that a line underneath means you include the endpoint, only if that endpoint made us 0. So how about negative 6? Does it make us 0? It does. And we're going to go all the way up to negative 5. And negative 5 makes us 0. Now I'm negative across the 0, but I'm positive from 1 on. But remember, 1 is a vertical asymptote, therefore not part of our domain. And so I can't include it. So this is the answer. I really apologize for not making that first one a negative, but super happy I checked the negative 5.5. Otherwise, I would have caused some confusion. So this is the 4.5 section. Should go very quickly for you.